Hi friend, have you ever had a data set in SQL and thought this would be so much easier to understand if the rows were columns or vice versa? This is where SQL pivot and unpivot come into play, and in this video I'd like to show you what you can do with it and how to use it. Okay, now I have a small little table here with 4 columns. We have a salesperson, the year column, months, and the revenue that salesperson generated in the given year and months from the sales table. Let's have a look. 4 columns, and we have a table that is 108 rows long. Our goal with the transformation now is the salesperson. We have 3 different salespersons here, Archer Lamble, Jack Potter, and Hudson Onslow. We want to transform them into columns with their respective revenue in the given year and months. This is where we can use the pivot statement. Okay, let's start with select something from our sales table. And now comes the pivot statement. We open this and need to give it a name, typically something like PVT, so you know what it is. And in here, we define how we want to pivot our data. First, we need an aggregation. We could, for example, use a sum. You could also use average and min, max, all the aggregations that you know. We want to sum our revenue. And the second thing that we need is to define how we want to spread. So we want to pivot it for our salespersons. And we need to define which ones we are interested in. Now we need to take the data, the Archer Lamble in here. We want to have a column with Jack Potter and another one with Hudson Onslow. So these are the columns that we want to generate from the data found in the salesperson column. Let's run this. And now we see we still have our year and months column, and our revenue is not a column anymore. The revenue went into the details of the 3 new columns for Archer Lamble, Jack Potter, and Hudson Onslow. Let's run those 2 queries together, and we see Archer Lamble in the year 2022 in the month 1 had a revenue of 424. This is exactly what we find here in the year 2022 in the month 1. Archer Lamble had 424. Now, for demonstration purposes, I would like to show you what would have needed to be done if we would not use the pivot statement. Let's say we want to achieve the same result. And I have prepared it here so you don't see me typing all the time. Copy it in. And this small little statement in the end is equal to this rather big one. What's happening here? Here we take our sales data and we need to group it by month and year. The order does not matter. But for our 3 new columns that we generated here, we need to define them as case when statement. So if the salesperson is Archer Lamble, then give me the revenue. Otherwise, give me 0 and do the sum of it and call it Archer Lamble. And the same then for the other 3. So you see, without pivot, we have to write a lot more. And if you imagine this list goes on and on and on, more than 3, this one gets bigger much faster. So using pivot really gives us the benefit of having a more concise SQL statement. Let me remove this one again. And now let's see only this result again. We have here the year and months column. But in my SQL query, I never mentioned year or months. This is happening because it always takes all the columns it finds from the sales table. And if it's not in the aggregation nor in the spreading definition, it will always add them as individual columns or keep them. What do we do if we want to maybe aggregate by year and exclude the months? In this case, we need to reduce the columns retrieved from our source. That's why often when you use a pivot, you use it with a subquery, or in this case, I will use a CTE, a common table expression. Let's do this with reduced sales as, and now I need to define the columns that I'm interested in. I'm not interested in all the columns, but let's say I only want to have my 4 columns minus the months column. If I run this, we still have 108 rows, but the months is missing. And now with these reduced sales, I will use this subquery, running this. Now we see, okay, Archer Lamble in the year 2021 had 4,814 revenue. And now you see why we put in here an aggregate function. Everything is aggregated now by the year. Okay, that is the pivot statement in SQL. As you saw, we can transform rows into columns. The syntax is a little bit difficult to understand at first, but with a little bit of practice, you will soon master the pivot statement. If you're new to this channel, my name is Henning, aka Don Data, and I'm here to help you understand SQL better and to optimize your SQL queries. Up next is the UNPIVOT statement, and it's often considered to be the opposite operation, which is not entirely true, and I will show you in a moment, but in general, yes, you can transform columns back into rows. Let's have a look. Okay, to show you how we can make columns into rows using the UNPIVOT statement, first of all, we need a dataset that is already pivoted, like our result here. And therefore, I will save it as a temp table, and let's call it pivoted data. Running this, I will just get it into my pivoted data temp table, and let's have a look what we have here. It should not surprise us. It's the result from the last query. Now we want to unpivot this one, and this is where the unpivot statement comes into play, and let's call it unpivoted. In this case, we will create a new revenue column for the salesperson in, and now the list of our columns. So in this case, we are searching for the 3 columns: Archer Lamble, Jack Porter, and Hudson Onslow. These 3 columns. So this statement says, give me a new column salesperson, which contains the results of these 3 columns, and the data that you find, put them in the revenue column. Running this, we transformed the columns back into rows. So let's put it side by side, and you see what we did here. This one is the pivoted data, and we put it back with unpivot into rows. And now you see, while we can move from the pivoted to the unpivoted statement as often as we want, we will never get back to the original state in which we had 108 rows, because in the meantime we removed the months column, and we will never be able to retrieve it again with the unpivot. So yeah, something to keep in mind. All right, that is the unpivot statement. Now you've learned how to use pivot and unpivot. But now comes a big but. What happens if in our initial pivots, let's take just this one and run this again. What happens if in the future we have a new salesperson, or a current employee is leaving the company, or we have a person that changes his last name, maybe for marriage? This will not be automatically reflected. So for a one-time query, this is perfectly fine. But if you want to run this query for many years unchanged, that would not work. You would always have to go here and add new person. Here I need to add a new person. Otherwise, the dataset would be incomplete. So let's say we always had 2 persons and later Hudson Onslow joined the company and we keep running it like this. Hudson Onslow, although he's generating revenue, he is not considered here. And this is now where, unfortunately, if we want to cover those cases and run the same query for years without changing it, we need to enter the territory of dynamic SQL. So we generate our SQL query before running it. To do that, we first need to have a list of our current employees. And I will generate a variable here and make it a larger max. So it can be very, very big. We don't need to worry about having hundreds of employees. It will fit in here. And this is for now just an empty variable. So I declared a variable per salesperson list of the type varchar, and it contains nothing. And now let me copy over something from here. We want to fill this variable. And we do this by selecting all the salespersons that we currently have, including Hudson Onslow. And in the future, new employees join, they join the sales process, they generate sales revenue, and they will appear here in the future. And with this subquery, I will take the distinct name, so I only get one record for one person, and I put it into our salesperson list by using a function called string aggregation. And I put them together with this rather strange syntax here. I'm having a closing tag and a comma and an opening tag from this table. And afterwards, let's just have a look what I just did here. Let's select this salesperson list. Running this, we are dynamically querying our columns, except for the starting and ending hard brackets. But we get to that in a moment. Now we need to use this list to build our query. And here I'm building an SQL query, which is just a text for the moment. And the text starts here. This might look familiar to you. We have the select star from sales and then the pivot statement. But here comes the dynamic part. I have an opening hard bracket and a closing hard bracket. And in between, I put the result of the salesperson person list. So this result, you can imagine, will then be dynamically put in here, including the statement that it's a string. And then this together is our query. Okay. Let's run it until here. And this is a SQL query that we were dynamically generating. Let's have a look at what it is. It's now only in one row, but this does not matter. It works. But this is exactly the query that we had before. And this is something with T-SQL. It looks like this. Execute and stored procedure called execute SQL with our SQL statement. Running this. All this gives us the respective output. This is now quite complicated, I know, but yeah, unfortunately, this is what you have to do when you want to run dynamic SQL. Now let's see if this even works. So let's say we have a new employee and he's generating also revenue. And let me just put it down here. So insert into our sales table. In those columns, we have a new salesperson called our new person. He generated in 2023 in the month 1 a revenue of, let's say, 1, 2, 3, 4. I insert this value, and then we run our dynamic query without changing it again. And yeah, obviously we don't need to the debug selects in between. This would be the whole thing that we need, running it. And we see, without changing our code, here is a new person. So there's new data for a new person called new person with revenue in that month. And here we have it. And this is our dynamic SQL query. As this query is obviously quite complicated, I will copy paste it into a GitHub repository where you can just copy it and adapt it to your needs, which, yeah, obviously you need to do, but then you have a baseline where you can start. Okay, so this is how you can use the pivot, unpivot, and even dynamic pivot statements. That leaves the question, is there also a dynamic unpivot if there's a dynamic pivot? I have to say yes, but that one would be very complicated and tied to the database system at hand. So I could make a video for the T-SQL version if you're interested. Please put it in the comments if there is demand for it. I guess it's not, because it is quite complicated, but I'm open to do it if you really want to see it. Otherwise, if you have questions, put them in the comments. The last thing I would like to touch is, you might be wondering, why should I even use this pivot, unpivot, and even dynamic pivot functionalities if I can do it all in my reporting tool like Tableau or Power BI, whatever you're using? Well, imagine if you have millions and millions and millions of rows and you could just aggregate and group them together to a few 100, 1000 rows. In that case, while you could do it in your reporting tool, you would be well advised to do it directly on the database server, so you don't move millions and millions of rows from one tool to the next to aggregate it over there, but to just have it at the source reduced and then send a smaller package of data over the net towards your end tool. And that's it for this video. If you liked it, please consider liking and subscribing. This would help the visibility of this video as you heard before, and wish you a nice day.